Hello and welcome to the Fieldcast LinkedIn Live series, where Fieldcast faculties are coming to you live on LinkedIn on the first and third Wednesdays of each month at 12:30 p.m. Eastern Time. I'm Yehua Wei, associate professor from the decision science area in the Fieldcast School of Business, and I'm very happy to be speaking to you at this session. The session will go until 1, and the plan is that for the first 20 minutes, I will present, and then I will be answering your questions in the last 10 minutes. So you should feel free to leave your questions at any time during the talk, and I will try to answer as many of them as possible in the last 10 minutes. So briefly, my general research direction is to use analytics and models to help businesses to make better decisions. And today, I would like to discuss a strategy for organizations to manage uncertainty. So for many organizations, the ability to deal with uncertainty is key to their survival. This was clearly illustrated through the COVID pandemic, as many that failed to adapt, unfortunately, had to close their businesses. But even before COVID, there was a clear trend that business environments are becoming increasingly volatile. And this is because we live in an increasingly globalized economy where any uncertain events in any particular region could affect the entire globe. And also with the technological transformations that are appearing at warp speed. So the specific strategy for managing uncertainty that I want to talk about today is the use of a flexibility network. The word flexibility is pretty common in business world and may mean many things. What I will discuss today is resource flexibility. That is the ability of having resources to perform different types of tasks. It's a very simple idea, but it's very applicable to many settings where organizations have different types of resources. So now let me illustrate resource flexibility in a simple baseball example on my slides. Okay. So imagine that you are the general manager of a baseball team, okay? And your resource are the players. So now I understand that we have an audience of diverse background here. So if you don't know baseball well, don't worry. You can think about a team sports that you know of, like, for example, soccer or basketball, where you're managing a team of players that are playing at potentially different positions. Okay. So going back to the baseball example, so let's just make the example simple. In general, a baseball team needs to put 9 position players on the field. But here, let's imagine that this is just we're just filling up 4 positions: the third base, the shortstop, second base, and first base. Okay, and we have 5 players: Alice, Bob, Carol, Dave, and Eve. Where the first 4 players, they play third base, shortstop, second base, and first base. And there are like our starters. They are the ones that are scheduled to be playing on each day. And finally, we have Eve, who is a bench player. And Eve's position is third base. Okay, so Eve is on the bench. And the bench players are typically in the event when some of the starters gets injured. Okay, so now let's imagine an injury scenario. So let's imagine a scenario where the second baseman Carol gets injured. Okay, so in that case, Carol can no longer play. So we need to substitute Carol with Eve on our bench here. So now we still have enough players to put on the field and play the game. But the problem here is that Eve's primary position is third base. So Eve is not comfortable with playing at the second base. So in other words, or in the baseball words, Eve is playing out of position. And this would affect our team's performance. Okay, so as manager, we want the team to win as many games as possible, and this is definitely not helped by having players to play out of position. Okay. So what can we do to avoid this type of undesirable situation? Well, the idea is to make our players, the resource, more flexible. Okay, so in particular, we could, as managers, we could talk to Eve before the start of the baseball season. Say, maybe you can work with the coaches to be more flexible and to be more comfortable with playing multiple positions. Okay, so an extreme case would be, let's ask Eve to be comfortable playing all 4 positions. Okay, third base, shortstop, second base, and first base. But that's a lot to be asked from Eve. So in general, if you look at the Major League Baseball, where the league with the best baseball players in the world, at most, like less than 1% of players are comfortable with playing 4 positions, 4 different positions at the same time. Okay, so to asking Eve to play all 4 positions is a lot to ask for a player. Some very rare players can do it, but this is not always the case. So alternatively, what we can do is we could also ask some of our other players to be more flexible. Okay, so for example, we could ask Alice to practice play second base before the start of the season, or just get some practice on second base before each game. Okay, so if Alice is comfortable at playing at second base, then we can manage an injury scenario to Carol by sliding Alice to the second base. And then we can put Eve to play the third base. So now we are in a better situation where we have 4 players playing at 4 positions that they are comfortable with. And this will not degrade the team performance as much as compared to the previous scenario where we had to play Eve out of position. Okay. So this is the key concept of flexibility. And like I said, this concept can be applied to many business settings. Okay. So next, what I want to do is I want to introduce some simple rules for harnessing the power of flexibility network. Okay. And to do that, I will stay with this baseball example. Okay. But now let's look at a more complicated setting. So where we have flexibilities in different players. Okay, so here, let's imagine that working with the coaches and deciding which player can handle multiple positions, we configure our team in such a way that Alice can play 2 different positions, third base and second base. Bob can play shortstop and first base. Carol can play second base and shortstop. And finally, Dave and Eve are kind of determined to be not flexible. They only have 1 position. Okay. So more abstractly, this table can be viewed as a network, a flexibility network. Okay. So the players are the resources, and the demand are the tasks. You think this is the positions that I need to fill in. And the network just kind of connects the nodes. So Alice can play third base and second base. So it's connected to those 2 nodes, Bob, shortstop, and first base, and so on. So it turns out that this network is very good in the sense that for any injuries to any players, I can still put on a team such that no one is playing out of position. Or in other words, all players that are not injured, I can put them on so that they are all playing at a position that they are comfortable with. Okay. And the reason to explain why this is the case, why this network is good, can be understood using, from academic term, using this idea of chain. Okay, so in particular, this network is a chain network, And what do I mean by that is basically all the resource nodes are either directly or indirectly connected to all the demand nodes. Okay, so to explain a little bit more, so the idea is that Alice is directly connected to third base and second base, but Alice is also indirectly connected to shortstop. And the reason being is that Alice is connected to second base, and by playing second base, this would free up Carol to play the shortstop. Okay, so it's indirectly connected through second base, Carol, and then shortstop. And similarly, Alice is connected to first base, but indirectly connected to Carol, to shortstop, and then to Bob, and Bob can play first base. Okay, so a chain network, again, is a network that indirectly connects all the resource nodes with all the demand nodes. And it has been observed through various studies that chain network tend to be very helpful in managing a large number of uncertain scenarios. And another way to think about why chain network is so powerful is that because we chain all the nodes together, this allows us to have lots of different options to reconfigure our resource in the event of some uncertainty occurs. Okay, so this is the first rule that I want to introduce on thinking about creating a flexibility network. Okay, another thing I want to mention about a flexibility network, so a chain network, is that there are many different possible chains. So there's not just one way of creating a chain. There are, in fact, many different ways. And in this baseball example, you can think about there's many different ways of reconfiguring my roster, training my players to create a chain. Okay, so another chain, this is kind of briefly mentioned before as well, is where I have Eve to play all 4 different positions. And in this case, Eve is kind of this focal player that allows me to connect all the players with all these different positions. And here's yet another chain. And this is a chain where Dave acquired the flexibility of playing third base, and Eve now just need to play 3 different positions. So again, this is a chain. So regardless of which chain we're looking at, I think one of the key points is that to build a chain, we don't need to add too much flexibility into our resources. So for example, we don't need all of our players to be capable of playing all of the positions. Okay, so really we just need to add a sparse or a little bit of flexibility. And this little bit of flexibility is really all we need, because adding a little bit of flexibility is already enough to deal with injury to any one of our players. Okay. So hopefully this illustrates some important concept and rules for building a flexibility network for managing uncertainty in different applications. And next, I want to also mention, I want to show you an example where we have a more complex business setting where this idea of flexibility is applied. So this is based on a recent publication of mine in a collaboration with a large e-retailer. Okay, so to provide you with a simplified picture of how this e-retailer works, so the idea is that this retailer has multiple distribution centers. So let's say it has 5 distribution centers, so 2 in the north, 3 in the south. And initially, the retailer has configured its network so that each distribution center is dedicated to fulfilling orders in its own zone. And the retailer wants to understand that what if I can add some flexibility into my DCs, distribution centers? So for example, what if I add some flexibility for the 2 retailers in the north? Okay, so the 2 retailers in the north, so this retailer can not only fulfill the orders in its own zone, but also the orders in this other zone, and same with the other retailer, and also similarly add some flexibility among the retailers in the south. Okay, so the retailer wants to understand what is the value of adding these flexibilities. Okay, so in this case, this is a much more complicated environment. It's much more sophisticated than baseball because this is in here after adding flexibility, the decisions the retailer face are highly complex. So customers are arriving somewhat randomly online to place those orders at different regions, and the retailers do not know really so which where would the next customer arrive. Okay, and upon arrival, upon the customer placing order, the retailer would then need to decide which distribution center is going to fulfill that specific order. So it's a very complex, dynamic environment that the retailer is managing here. And to really understand the value of flexibility, it's not enough just by looking at a network or doing simple scenario analysis. So in this case, we actually have to use a lot of the analytical tools. So analytics is essential to understand the power of flexibility in a complex environment. So in our particular example, we have to build a data-driven model that performs a lot of Monte Carlo simulations to understand how much increase in profit would this flexibility bring to the e-retailer. And another very interesting finding we found through this example is that we also find that once we add flexibility to a complex environment like this, it is crucial to think about the decisions downstream, to think about the decisions that occurs after we add flexibility. Because after adding flexibility, decision actually becomes more complex. Now you have more options. So it's very important to think about how to optimize the downstream decisions, and only by optimizing the downstream decisions would give you your flexibility more value. And in this particular case, we actually find that if the downstream decisions are not optimized, like the fulfillment decisions, where you think about which distribution center are fulfilling which orders, if we don't really optimize that, then there could be scenarios where adding flexibility could actually decrease the e-retailer's profit. Okay, so therefore downstream decisions here are absolutely crucial for capturing the value of flexibility. So in summary, the flexibility gives you more options, more choices to respond to uncertainty, but it's very important to consider downstream decisions after the uncertainty is realized, especially you have a complex business environment. Okay, so with that, I will end my presentation here. Please feel free to post your questions at the comment section, and I'm happy to answer as many of them as I can. Okay, so so a question I have is that, can you give me more examples of flexibility network? Okay, so let me provide a couple concrete examples. So for example, for manufacturing facilities, you can think about making the manufacturing facility to produce different type of products. Okay, so having the flexibility of producing different type of products could be very important for a manufacturer to better match its available capacities in its production facility with the changing demand or the changing demand patterns. Okay. Another example could be for a call center, where we have call center agents to handle different types of customers. So again, this allows the call center to reduce the wait time to better, because this can allow the call center to shuffle its call center agents to different type of demands and therefore reduce service time. And the third example would be that managing a vehicle fleet and having vehicles to have the flexibility to deliver to different zones. Okay, so this could, depending on the demand of the day, could potentially better serve the customers and also reduce things like the transportation cost of the overall fleet. Okay. Here's another question. Okay, so the challenge I see with this solution using the baseball analogy, when one player is hurt, does it make sense to shift 3 players to suboptimal situation rather than just have the sub replace the injured player's position and have only one position being played suboptimal? Yeah, it's a great question. Well, this really depends on, I guess, your flexibility configuration, right? And also, it's in the real world, of course, things are more complex. You need to talk to these players or getting information from the coaches to understand how comfortable are they about shifting positions. Yes, of course, in general, you don't want to shift 3 players all at once. And this could be potentially mitigated by adding maybe a little bit more flexibility than the network I have shown in the presentation. Right? If you add a little bit of flexibility, you could take into this constraint, just make sure every time when I shift, I do not shift, I shift at most 2 players, or maybe I shift at most 1 player and bring in the sub. Okay. And this really depends on different flexibility configurations. And to truly understand the value of the flexible configuration of your baseball roster, then I think, again, like using analytics, things like Monte Carlo simulation will be very helpful. So this allows you to analyze for every scenario what would happen and understand what is the weaknesses of your roster and what is the strengths or how robust it is with respect to injuries. Okay. Another question I have is that how do you compensate the flexible employees? This is a great question. Okay, so if you think about the flexible employees, so sometimes maybe the employees do not want to show that they are flexible because they don't want to be the one that kept getting shuffled around, right? So then one possible way is that you want to, again, using analytics to measure the potential value of a flexible employee bring to you and compensate that appropriately, right? If the employees see that by being flexible, they are getting more compensated and compensated fairly, then they would be more willing to be more flexible, okay? And to encourage, right, flexibility among employees in the company is very important in managing the uncertainty. Okay, one more question. Okay, so so how do I know where to add flexibility in a complex environment like the one you described? Okay, so yeah, that's indeed that is it's difficult. So I guess it really depends on the situation. So in the particular example I described about the e-retailer, because of the transportation cost, it kind of, for the company initially had a hunch that they want to create a flexibility between the distribution center that are reasonably close with each other. Okay, so in that particular example I showed, it was the 2 distributions in the north and then the 3 in the south. And but then we can always just try many different flexibility networks, and then use analytical models that one built. Like for example, in my example, so we build a large simulation model that allows us to simulate the value of any flexible network that one can propose. Okay, so then it really becomes analytics and computational power. So using those to better understand the value of a flexibility network over there. Okay. Okay. So I see that there are no more questions. So thank you so much for attending this session. I just want to conclude here that I hope you enjoyed this session of LinkedIn series. Just want to let you know that the Fieldcloud LinkedIn Live series will be back on Wednesday, July 7th at 12:30 Eastern Time with the marketing professor, Jordan Atkin. If you haven't done so, please follow us on LinkedIn or follow Fieldcloud on LinkedIn to be alerted to these and other events. Again, thank you for your attention.